That green glow isn't a reflection. It isn't a cloud. It's helium, leaking off the edge of another world, 48 light years from where you're sitting right now. So this is LHS 1140b, and for the first time in human history, astronomers just confirmed something we've been chasing for decades: a genuine atmosphere on a rocky planet sitting inside another star's habitable zone. Not a guess, not a simulation, a measurement published in the journal Science. And it's already being called one of the biggest exoplanet results in years. 48 light years sounds abstract until you put it in human terms. The light carrying this discovery left that planet system decades ago. Every photon astronomers just analyzed started its journey before most of the people watching this video were even born. That helium wasn't leaking off LHS 1140b this morning. It was leaking off it back then. And it's still leaking now, this exact second, completely indifferent to whether we ever noticed. Let that sink in for a second. We've cataloged over 6,000 exoplanets now. A handful of them sit in that narrow, precious zone where liquid water could exist. But being in the right place was never the same as holding on to air. You can park a planet perfectly in the habitable zone and still end up with a dead, stripped rock. No atmosphere means no weather, no shielding from radiation, no chemistry, nothing that looks like life as we understand it. So why has this never been confirmed before? Why did it take until now? Because proving an atmosphere exists on a planet you'll never visit, orbiting a star you can barely see, is one of the hardest measurements in modern astronomy. This particular world was first found back in 2017, spotted by a survey called the Mirth Project. Back then, astronomers only had rough numbers: a planet almost 6 times the mass of Earth, about 70% wider, circling a small red star every 25 days. For years, nobody even agreed on what kind of world it was. Some early data even suggested it might be a mini Neptune, wrapped in a thick blanket of hydrogen gas. Not exactly the kind of place you get excited about. Then the picture changed. Refined measurements showed a lower density than expected, and that opened a strange new possibility. Not a gas-choked mini Neptune. Maybe a genuine ocean world with somewhere between 9 and 19% of its entire mass locked up as water. Nobody could confirm any of that yet. What they had was a rocky candidate, sitting at a temperature of about minus 47 degrees Celsius, catching just over 40% of the sunlight Earth gets. Cold, dim, but sitting just barely inside that narrow habitable band. Here's something most people get wrong about planets like this. Red dwarf stars have a nasty reputation. They're small, but they're violent, blasting nearby planets with flares and high-energy radiation that can strip an atmosphere away before it ever has a chance to matter. That's the exact reason so many red dwarf worlds get written off before they're even studied properly. But when astronomers pointed X-ray and ultraviolet instruments at LHS 1140's star, they found something unusual. Across weeks of monitoring, it barely flickered. No major flares. This star sits among the calmest of its kind ever measured, and that calm may be exactly why an atmosphere on this planet could survive at all, instead of getting torn apart the way it would around a more hostile red dwarf. That detail matters more than it sounds. Red dwarfs are the most common stars in the entire galaxy, and most of the habitable zone planets found so far orbit one. If atmospheres routinely survive around the calmer ones, that doesn't just change the outlook for LHS 1140b, it changes the odds for a huge slice of the planets already sitting on astronomers' watch lists. And this is where the story stops being a background fact and starts being a calculation. A Harvard-led research team working the numbers on LHS 1140b predicted something specific before anyone proved a thing. They said this planet should have an upper atmosphere rich in helium, slowly bleeding away into space over time. Not vaguely possible, predicted, on paper, before any instrument had verified it. Here's the thing, even the researchers on their own team weren't sold right away. One of the senior astronomers involved openly admitted he was skeptical. Because a prediction is just math until something out there agrees with it, so they went looking for the proof. Back in 2024, the team quietly pointed the Winterred spectrograph, mounted on the Magellan Clay telescope in the mountains of Chile, straight at LHS 1140b, and then something happened that almost never happens. On the exact night of their observation run, LHS 1140b and a neighboring rocky planet in the same system both crossed in front of their star at once. Think about how rare that is. 2 planets, one night, one direct side-by-side comparison with no guesswork in between. One of those 2 planets showed nothing, no atmosphere, just bare rock, silent against the starlight. The other was LHS 1140b, and LHS 1140b lit up with the unmistakable signature of helium, thinning at high altitude and escaping into space. Not a hint. Not noise buried in the data. A clear, measurable atmosphere, one that has to be constantly replenished from somewhere deep inside the planet, just to still be leaking after all this time. The skeptic on the team came back with a very different word for it. He called the results statistically rock solid. Now sit with that for a second, because LHS 1140b isn't the first world to get this kind of attention. Before this, the loudest name in the search for life was K218b, a claim of a possible biological gas that made headlines everywhere. A later reanalysis found that signal too weak to hold up, and showed the same gas can form with zero biology involved. The 7 rocky worlds of the TRAPPIST-1 system have their own mixed record too. One of them has already been ruled out for an Earth-like atmosphere. Another is still stuck in frustrating uncertainty, neither proven nor ruled out. LHS 1140b just became the first world in this entire group, with solid evidence of an atmosphere behind it. Not a maybe. Not a reanalysis waiting to fall apart later. Peer-reviewed and published for the whole scientific community to scrutinize. This is the part where most stories stop. A discovery, a headline, done. But here's where it gets downright interesting. Think about what the method itself really means. Astronomers didn't fly a probe out there. They didn't land anything on the surface. They caught a single fleeting alignment. 2 planets crossing their star on the same night, from 48 light years away, and pulled a chemical signature out of starlight, passing through a sliver of atmosphere thinner than the edge of a coin held at arm's length. That's the level of precision we're talking about. If you can catch escaping gas from a planet this small, this far away, using one lucky night and the right instrument, that technique doesn't just work once. It opens the door to checking other rocky worlds the exact same way. This isn't a one-time trick. It's a new tool for an entire field of astronomy, and every habitable zone candidate discovered from here on gets measured against what just happened here. And the team isn't stopping at, there's an atmosphere. They're already working on what that atmosphere is made of. Not just the helium leaking off the top, but the full composition, layer by layer. Follow-up observations are already being planned, aimed at nailing down precisely which gases are down there and in what amounts. And underneath all of that sits the bigger question. Could LHS 1140b be holding liquid oceans right now, on its surface? Here's why that question matters more than it might sound like at first. Astronomers have a short list of criteria for what makes a planet worth obsessing over in the search for life. It has to be rocky, not a ball of gas. It has to sit at the right distance from its star for liquid water to survive on the surface. And it has to actually hold an atmosphere long enough for chemistry to happen. LHS 1140b now checks every single box on that list, and it's the first planet outside our solar system that can say that with real evidence behind it. Not just favorable geometry. Stop and think about what that would mean. A rocky planet in the habitable zone, cold enough for liquid water, with an atmosphere now proven to survive far longer than anyone expected, and possibly enough water locked inside it to rival Earth's oceans. That's not just a data point anymore. That's the exact combination scientists have been hunting for since the very idea of a habitable exoplanet existed. We are not there yet. Nobody is claiming oceans. Nobody is claiming life. Helium alone can't support anything. This is still one careful, patient measurement, not a headline about aliens. But for the first time ever, a rocky world outside our solar system has shown it can hold onto air. Before this, habitable zone was just geometry. A distance from a star, calculated on paper, nothing more. Now for one single planet out of 6,000, it's something closer to true. LHS 1140b sits in that zone, orbits a surprisingly calm little star, and kept its atmosphere anyway. So look at that green light one more time. It's not decoration. It's not an effect. It's gas, right now, bleeding off the edge of a planet 48 light years from your window, on a world discovered less than a decade ago and only now starting to reveal what it actually is. We don't know what's underneath those escaping wisps of helium. We don't know if there's an ocean down there or just more rock, colder and stranger than anything in our own solar system. And we definitely don't know if anything at all, is breathing that air. That glow isn't the answer. It's the first real question we've ever been able to ask about a world like this. And somewhere out there, 48 light years away, it's still glowing.